Hey folks, so this is your lesson video for section 11.2. I believe I'm going to be breaking this up into two videos. The first one will be for the law of cosines, and then the second portion will just be the area portion. What I'd like to point out is the sticky note over to the side, and that the first thing in the sticky note is that the law of cosines can find obtuse angles. You remember back in section 11.1, the law of sines cannot find obtuse angles. And then the second part of the sticky note says that if you play your cards right, you should only ever have to use the law of cosines one time per triangle. The law of cosines is the clunkier law. The law of sines is prettier. And so if you do this correctly, you should only have to use the law of cosines one time, if at all. I've already given you the formulas, so let's go ahead and just jump right on into example number 1. Example number 1, you'll notice that I've already taken what's given and I've set up my chart, filled in what I have missing. And so you'll notice as I look at my chart, there's no way that I can use the law of sines because I don't have any one fraction that has a full set of values. And so because of the fact that I don't have enough to use the law of sines, I'm going to need to use the law of cosines. And so you ask, well, which law of cosines should I use? And since I've been handed angle A, I'm going to use the one that has angle A in it. So we'll come over here to the side and we'll go ahead and start plugging in. So we have A squared is equal to, there's my B squared plus my C squared minus my 2, and you'll notice here this is my B, this is my C, and then this is my angle A. All right, go ahead and pull your calculator out, and then just type all of that in, and you'll get 6.7460. But remember, this is A squared, and so if that's A squared, you need to take the square root of both sides so that you can get your plain old A value. Well, now that I have my A value, I can go and put that into my chart. And now all of a sudden, I've got enough information to be able to use the law of sines. Now, I want you to be careful. Remember that the law of sines cannot find an obtuse angle. So take a look here back at our chart. Is there a possibility that one of my unknown angles might be obtuse? And how would you know that? Well, you remember the whole small opposite small, medium opposite medium, large opposite large. Look at the largest side. The largest side is side C, so therefore the largest angle is going to be angle C. And since I don't know what angle C is, it's totally possible that this one might be obtuse. So if I'm going to be using the law of sines, do not go try to find angle C. It might be obtuse, and the law of sines cannot find an obtuse angle. So I'm going to use these two for my fractions. I know that angle B is acute, and so I'll use these two for my law of sines fractions. So we'll come down here to the work, and there is my B fraction. There's my A fraction. Notice that I put the unknown on top, which is why the angles are on top. Multiply on both sides by 2.78. Plug that into your calculator. You're going to get an ugly decimal. And then do the inverse sign to be able to get your angle B. Now that I have 2 of my 3 angles, I can find my third angle not by using the law of sines, but simply by adding and subtracting. And so I'm just going to do 180 minus my angle A and my angle B, and that will give me my angle C. So that now everything that was unknown is now found. I found my angle B, I found my angle C, and I also first found my side A. So these are my 3 answers in this particular example. Let's go over to example number 2. Example number 2, you'll notice that all 3 of my givens are sides. And so notice the little sticky. I've already said it, but I'm giving it to you again because it's such a big deal. You should use the law of cosines, first of all, to find the obtuse. If you waste it on finding an acute, you might have to use it again. So when we look at our chart, which I've already set up, which angle might be the acute angle? And we see that it might be angle C because it's opposite the largest side. So let's go find angle C first, and we'll use the law of cosines to do that. So right underneath then, I'm using the law of cosines that starts out with C squared. So I have my C squared equals my A squared plus my B squared minus my 2AB cosine C. Now, you have to do a little bit of maneuvering. But notice that the unknown is your cosine C. This is the guy that has to be isolated first. So what I'm going to do is let's move these two guys to the other side, first of all, by subtraction. So there's my 58 squared, and I'm going to subtract my 28 squared and my 47 squared. That's going to leave on the right-hand side just my negative 2 times 28 times 47 cosine C. And then I'll divide on both sides by that multiplying stuff. And so that way then these will be canceled out because I'm dividing on both sides by this guy. All right, so now I have my cosine of C, and I can plug all this into my calculator and I'll get negative 0.1410. Make sure that you can get that number. We'll do the inverse cosine, and we'll get that our angle C is 98.1033. And lo and behold, that was obtuse. Okay? All right, now I can go back to using the law of sines. First of all, I now know that angle A and angle B, these guys are both going to be acute, so I can find either one of them first. It does not matter which. And I need to use the C fraction. So I'll either use the C fraction and the B fraction, or I'll use the C fraction and the A fraction. Either one will work. It doesn't matter. So we come over to here then, and we'll use the C fraction and the A fraction. So that's what you see. By the way, if I were you, I would store any angles that you find, really any numbers that you find, because in this case, you're going to need it again. So you can tell here that I have stored my angle C simply because of the fact that I'm not writing the whole thing that's in my calculator. All right, so we'll go ahead and multiply on both sides by 28. And this is going to give me my sine of angle A. Plug that into your calculator and then use the sine inverse. We can come back up to our angle A and unhide that. And then to get angle B, all I need to do is subtract angles A and C from 180. This is when it's nice if you've stored these numbers in the calculator. And so my angle B is going to be this 53 number. All right, let's move. Example number 3 has already been handed to you. It's very similar to example number 4, so I'm not going to work through that one. Let's work through example number 4. So I wanted to draw this picture for you myself. It's much easier when I walk you through drawing the picture, so that's what I'm going to do for this particular example. So let's go ahead and start reading. You have two ships that leave a harbor together. They travel on courses that have an angle of 135 degrees, 40 minutes between them. All right, so let's just go ahead and draw that much of it. So let's say that right here, let's say that this is my the harbor where the ships are both docked. And I know that when they leave, they're both going to travel 402 miles. And not only that, I also know that the angle that separates them is 135 degrees, 40 minutes. Now, I'll call the upper ship, ship A, and the lower ship, ship B. And then the harbor I'll just call C. Now let's go and read what the question is. If they travel 402 miles, how far apart are they? And so essentially what I want then is I want my side C. So I don't need to find everything. I'm just simply going to find exactly what I'm required to find. Now there's a couple of ways that you can do this. One thing that comes to mind, and let me go ahead, I'm going to unhide some of my information here. All of that was given. One thing that you notice, since this is an isosceles triangle, you know that angle A and angle B have to be the same measure. So if you simply then do 180 degrees minus angle C, all you need to do then is that'll give you angle A and B together. Simply cut that in half and it'll give you each of the angles A and B. So 180 minus your 135.40 gives you, I don't know, I didn't actually write that down, and then split that in half and you're going to get an angle A and an angle B, both of 22 degrees and 10 minutes. Okay. So now it's pretty easy to see that I can set up my law of sines, which I also did not show you here. So if I set up my law of sines, I would use the C fraction and one of the other two fractions. They're identical. And so I would have side C over the sine of 135.40 is equal to side 402 divided by the sine of 2210. Multiply on both sides by the sine of the 135 number. And so you're going to have 402 times the sine of 135.40, all divided by the sine of 2210. Okay. And I will leave you to enter that into your calculator, but I will unhide for you that side C is 744.5766 miles. And this is the final answer. This is how far apart those two ships are. All right, let's look at example 5 I'm not going to do. It's very similar to example 2, so I'm going to leave you to go through that one on your own.